Okay, so we want to find the efficiency of this, right? And the efficiency is a little bit tricky, right? So the efficiency is going to be the net amount of work done, okay? This is going to be the total amount of work done divided by the net amount of heat that flowed into the heat engine, okay? Well, the heat that flowed in is actually pretty easy. We can figure that out, right? Because the heat only flows in during AB. Okay, so let's do this, right? Let's go all of our cycles. We got AB, BC, CA, okay? And then let's do Q, let's do delta U, let's do work, okay? Sometimes it helps to just kind of organize this, right? So for AB, we knew that that was isothermal. So this was 0. They said that it did 416 joules of work, right? Remember that, they tell you that, right? So therefore Q has to, remember this has to equal this plus this, right? Okay, so we know that the Q is 416. And by the way, that's the only heat that flows in, right? Okay, now for BC, since the piston didn't move, we knew that was 0, right? Okay, and then we knew that it went from 612 to 385.53, right? So we figured out that this was negative 333.04, right? So this is negative 333.04, okay? Now for CA, we knew that the net heat flow is 0. And that's because, the reason that is that it's adiabatic, right? That's an adiabatic compression. So that's what that means, right? Okay, now let's think about this, right? We know that it goes, therefore, from a temperature of 385 to a temperature of 612. So this temperature is 612. This temperature here is 612, right? Because it's isothermal, okay? So we know, therefore, that the change in internal energy has to be positive 333.04, right? So therefore, the work done has to be negative 333.04. By the way, another argument for this change in internal energy being positive 333 is that the net for a complete cycle, this always has to add to 0. Because if you start and end at the same place, the net change in internal energy has to be 0. Okay? So that's another argument for why this has to be positive 333, right? Now, what we're going to do here is we're going to say that the net amount of work, okay, the total work is going to be this plus this, right? So our total work is 416 minus total amount of work is 82.964 joules. And we add this and this, right? Okay. And then the total heat that flowed in is still 416. You don't add these up, okay? This is wasted. That's why it's not 100% efficient, right? Okay. So now we're set. Now we can go efficiency is work. It's work divided by the heat that flowed in, right? Remember that? So it's not very efficient, right? So we take that, divide by 416, and we get 0.1994. So therefore it's 0.20, and there's no units. You could say 20% if you want to. I encourage you to use just a pure number. All right. Yeah. Okay. I think I was somewhat coherent.